So welcome everybody to my workshop, or Hidden in Plain Text, where I'll be introducing a Pgp/GPG. And thanks for everyone, thanks Hope Conference and everyone for coming. A little bit about myself. My name is Mark Lam. I graduate from NYU ITP Creative Technology program. So I'm a web developer and digital accessibility specialist. And I am an artist that uses code as my primary medium. So I'm interested in community networking projects and security projects as well. So I'm glad to be sharing some of the things I have learned. I guess the disclaimer is that I'm not by no means a professional cryptographer or like a cybersecurity professional. So there might be some things that might be a little bit beyond the scope of my knowledge, but hopefully if anyone else wants to chime in, if there's any questions, feel free to share the knowledge, I guess. My website is markofthelamb.com, and mark@markofthelamb.com is my email. Let me know if there's more problems seeing the slides. Okay, so I'll just keep going on. Hopefully it'll work out. If not, oh yeah, if you have a problem seeing the slides, in the shared notes and the big blue button, I posted a few links, which are the slides for the presentation, as well as a couple other links that we'll need. Yeah. So I guess I want to start out with a little discussion about encryption before we dive into PGP. And so I want to bring up this idea of sending a letter. And when we're thinking about digital communication, it's kind of the same as sending letter sending, where we're sending information across the network. So what, just from a privacy or security perspective, what are some things that you think can potentially go wrong from a mailing from your house to somewhere else, to your neighbor? If anyone wants to write in the chat, just something that can go, that might get wrong. Right, Sailor Amy says it could get lost. Very true. Stealing the mail, interception, wrong address. These are all very, very valid questions or concerns for letter sending. Right along the way, that's definitely a big problem. Wet and unreadable. Yeah, so these are all very good points. So when you look at it, we can kind of categorize those into more or less, or into three kind of buckets. Which I guess in terms of security, you can think about it as confidentiality, where someone is reading your mail, so you want to keep your communications confidential. So that could be problematic. It can go to the wrong person. This is a problem called authentication. So you want to make sure only, when you're communicating, you want to make sure that it goes to the right person, and only that person can be able to read it. And the concept of data integrity, which is someone can change the contents of your letter en route. Someone intercepts it, changes out of thinking about mail elections or something. Someone can change the ballot and send it along as you. So those are kind of the three three areas of security that we want to consider when we're thinking about encryption. So what exactly is encryption? This is like a kind of textbook definition where you're scrambling data so that only authorized parties can understand the information. I guess in technical terms, it's converting something what's called plain text to ciphertext. Ciphertext being the like the scrambled message, or like kind of illegible unless you have a key to it. So here is like kind of what it kind of looks like when you're want to send like a message, like Bob wants to send a note to Alice saying what's up. So if this would be plain text, just what's up, sending it to her, which can be problematic when you're using a network, like a computer network or a mail network, where it has to be exchanged through different various third parties to get to Alice. So there's this Noah that's in the middle, who might be able to read Bob's message to Alice. So a thing that we want to do, we can do to fix that is what we're talking about, the topic of our conversation, encryption. So if Bob took that message, what's up, and then he encrypted it, and then sent it along the way to Alice, and then we would be able to decrypt it, Noah in the middle wouldn't be able to read it. He'll see like scrambled letters. So that is kind of like encryption in a nutshell. And a little bit about how encryption looks like outside of a computer network or like modern encryption. There's like Pig Latin. It's a way to obfuscate your speech by using like a pattern. Like when you say what's up, you can replace it to that's way, up way, or how are you, ow, hey, our way, ooh, yeah. So this is kind of a form of encryption by you kind of using like a pattern or algorithm to change the message, so that kind of makes it more complicated to be understood unless someone else already knew how to decode it. I guess in history, there was this is a cipher disk, Caesar wheel. So way back in, I think, Greek times, they would encrypt their messages this way, and it would operate kind of like a wheel where this is the alphabet, and then you would turn the inner wheel that will give you like a code that you can scramble your message in. So you see like like a four rotation cipher. A would turn to D, B, E, F. So then the receiver would have to have like how far they rotated in order to unscramble a message. A little later on, quite a bit later on, there's Thomas Jefferson invented what is called a Jefferson disk, which operates in a similar way where there's a wheel with letters on it, and then you can like take apart the wheel and scramble it up to code your messages. It kind of looks like this. So this is used up until I think World War I, when they were still like using a cipher system like this, where you would kind of make a message, and then this would be your message, retreat now, and this would be kind of your encryption code to tell them how to unscramble a message. So actually, and like further down in World War II, I guess the Germans had they had the Enigma Machine, which operated similarly to the Jefferson disk, where every day they would scramble, have a new code to scramble the messages. And for a long time, for a while, it was considered like uncrackable. It was like very difficult because of their constantly changing code. And so there was like a World War II. There's like a big multinational scale effort to decode these messages. This is a picture of, I think that's from an imitation game where Alan Turing made a machine, a huge machine to try to decode these messages. And these were like kind of the basis of something like the early forms of computing was to scramble these and unscramble these messages. So now moving to like a more modern encryption, or how encryption is kind of used today on the internet or computers. So there is so a computer network have packets. So when you're communicating on the internet, you're kind of traveling across the networks of different computers. So encryption becomes like really important in keeping our messages private on the internet. So for example, if you want to message or communicate with wellsfargo.com, you'll probably be encrypting a message here, and then you'll be sending it across the network so that the various third parties wouldn't be able to read the message while you're communicating with Wells Fargo. Yeah, and I guess encryption also plays like an important role in email or other forms as well, which brings us to PGP a little bit later on. But in modern encryption, there is primarily two forms of encryption. One is symmetric encryption, which is similar to like the previous types of encryption we saw in history, where you would encrypt a message with a code, and you would have to know the same code to decrypt the message. And basically, you're using one key. So that's why it's called symmetric encryption. There's just one key to encrypt and decrypt. And then this has some like drawbacks for as well. One of like the primary one is that how do you like send the key as well as the message to somebody to decrypt, because then you'll have have to be sending two things over in order to communicate. So that comes up, it kind of gets solved with another more modern form of encryption called asymmetric encryption, also known as public key encryption, where you generate two keys. They're called a key pair of for key pair encryption, or for encryption basically. So you have what is your public key and then your private key or your secret key. So how that kind of would work is that you would need to have, so each party, like yourself and the person that gets sent to, go on the next one slide. So that there's yourself, and then the person you want to communicate, let's say Bob and Alice. So both of you would have, both Bob and Alice would have a public key and a private key. So you would want to keep your private key a secret that only you or only the person holds onto, but their public key can be distributed widely, or it can be sent out an email or on a server or on a website. Just you need to have it public, but only keep your private key for yourself. So how this would kind of work is you would have, if this is Bob and he wants to send a message to Alice, he would need Alice's public key, which he encrypts his message with. So then there would be an encrypted message that he can send anywhere, but only Alice, who has the private key or the pair of her key, can decrypt the message. Yeah, actually, I want to take a quick pause. I think I covered a lot of information at once. Has anyone wants to have any questions about symmetric or public key so far? Cool. Okay, yeah. So PGP, great. So PGP is a program. I think that is kind of the next. Well, I'll get to PGP in a couple of seconds. PGP is a program that is an encryption program that takes care of. Okay, public key encryption. Yes. How can someone display their public key? So actually, great question. Now this is kind of the next slide. So there's public key distribution. Like how would one distribute their key? So yeah. So the thing with public key or key pairs is you want to keep your private key to yourself, but your public key is be open for the public. So if anyone wants to send a message, like an encrypted message to you, they would need to have your public key, and not your private key. So what you could do to give people your public key is I see it's common, like for some people, to like attach their public key in their email in case someone wants to send an encrypted message back to them, or they can put it on their website, or there's a concept called Pgp Key Servers, where it's just a server that retains people's public keys and attached with their email addresses. So like there's a lot of ways to distribute your public key, and as long as you keep your private key safe, then you shouldn't have any problem, or there shouldn't be a fear for you to send your public key out publicly. Yeah, so Z asked if anyone has that private key, they would decrypt the public key. Yes. So if you had the private key for a public key, then and access to, I guess, the email, then you could decrypt a message. So I mean that is kind of, in some ways, I guess, like you'll think of it like if you want to use a different computer, then like you'll have to have that private key to encrypt that message if you're like using a different computer, for example. So then you can take your private key and can store it on, I don't know, a thumb drive or something, or you can keep it to yourself. But you would need that to decrypt a message that was encrypted to you. Yeah, their private key plus your public key. Yeah, exactly. So more or less, their private key and your public key. Okay, so it could only be read by you. And if they sign it with their private key, they actually only need to have your public key to encrypt the message. But if they have their private key, then they can sign it's called signing the message. to verify that it was sent to them. And I think a lot of these questions might be kind of make a little bit more sense when we actually start playing around with PGP. And then it'll be become a little bit more clear. Yeah. So no problem. Feel free to ask any questions. But I guess I wanted to bring this up, the slide that there's all moving on to, like, these are different algorithms, like algorithms for encryption that is available. AES, RSA are common ones, and they're kind of like what the algorithms that the computers use to encrypt, like to mathematically encrypt the messages. Which I don't think you really need to know about it too much, but it's just something to be aware of for the details of how it works under the hood. And going on to what is PGP encryption. PGP is a software that was released nearly 30 years ago in 1991 by Symantec, which is PGP stands for pretty good privacy. And actually, I think that's a kind of a misnomer. I think it's good. It's good. It's like I don't think that from what I've read, I don't think that there's actually been any known instances of it being cracked or anything. Awesome. Yes, I'll just show this slide that was shared here. Yeah, so here is kind of that look. So this would be encrypted, and then you need the two keys in order to encrypt and decrypt the message. But we'll see what that looks like. So PGP, yeah, it was made in 1991. So it's pretty solid for like text encryption, and it's like pretty much standard, like a pretty good standard for like email encryption. If you're familiar with Proton Mail, which provides like end-to-end encryption, they'll use email PGP. They'll use PGP as kind of their mechanism for encryption. And kind of like this term GPG, what is that? It's kind of confused. I mean, kind of confusing, but GPG is the GNU privacy guard, which is the GNU, like an open source implementation of the PGP standard. So you'll kind of see them used pretty often interchangeably. GPG is like, but you're gonna find it most commonly installed on like Linux machines, or it's like free to use. So like that's why a lot of people use GPG, but it basically is PGP. So what does it look like? So this is what a PGP key looks like. So this in ASCII. So an ASCII representation of PGP key. So you'll see it has a little header that tells you a little bit about it. And then it's just a scramble of like of letters and numbers. So this, it would be like the public key. That's something that you can like send out. I've seen like often it being used in people's email signatures or on their website if they want. And then this is what a PGP encrypted message could look like, or would look like. They would encrypt the message, and then they can send the scramble of words to somebody, and then it would be on them to to decrypt it. All right. Cool. I think I need just a quick check-in before. I think the next we're gonna open up Replit and start playing around PGP, and kind of see if we can. It makes a little bit more sense when we play with it. But any questions before we move on? So cool. So in the shared notes, I have a couple links that we'll be using. So first, I'll just drop this in here. This is going to be a sheet that we'll be using just to more easily send messages or send things to each other. Because in the past, I think chat has character limits, so I want to just bypass that here. If you open up the link I just sent you, it'll open up a Replit window. And Replit is, if you're not familiar with it, it's a online REPL or terminal or computer. So it just basically spins up kind of a Linux box for you to use. So I'll be kind of showing the command line interface for GPG, which you can install if you're using Linux. You can install it on Linux or Mac. There's also GUI versions of it as well, of how you can interface the PGP. But for now, we'll take a look at it through here, just because it's a little bit simpler. All right, so I'll give it a couple minutes. Let me know if let me just do a poll or something. Just see if you have it open and if you're ready to start looking at it. And I'll cool. So let me just, if you're unfamiliar with Replit, just a little bit about this interface. Here are some files I created for us. See on the left, there's a file navigator that I pre-made some things for us. And then if you open it up here, this would be an editor. So that you can type in, and then on the right is a terminal for a terminal. So let's and if you go to README, there's steps that I'll be guiding through it in case anyone you get lost. But feel free to just always drop a note if you're missing something. So cool. Yeah, so this should be okay. That's why I wanted to use Replit, because it's so I didn't want you to have to install any programs, so this will all work inside the browser. So here is, if you open up this demo.txt.asc, you'll see a encrypted PGP message. So you wouldn't be able to understand any of this, of course, until you decrypt it. So in order to decrypt it, try hopping over into this terminal and then type in this command, GPG -d for decrypt, and then demo.txt.asc. And then when you press that, it's going to ask for a phrase, and then the phrase is Hope 2020. And then you'll see that what this actually says is, hello, my secret friend. So this is the form of symmetric encryption that I was talking about earlier. So that means that anybody with the passphrase, so you can send this message anywhere, and then as long as they know the passphrase, then the receiver would be able to decrypt it using the PGP program. Yeah, let's try sending something. Let's take a look at like how do you encrypt something. So if you want to encrypt something using symmetric encryption, PGP. You can, if you open up symmetric or secret.txt, let me delete all of this. You open up to secret.txt file, it'll be a blank file, and then type in a message in here. And then how you would encrypt the message, you don't have to save it and ruffle it. So it'll automatically save. So now here, in order to encrypt the secret.txt, try type in this command GPG -- symmetric -- armor, and then secret.txt. So what this means is you're telling the GPG program to do a symmetric encryption, and then armor is like ASCII, so that will tell GPG to create an ASCII kind of file of secret.txt. So when I run that, it'll ask for a passphrase. I'll do hope 2020 again. So what happens now, it'll generate a new file called secret.txt.asc. So this is your encrypted message. So yeah, if you wrote a message, I want to just try it out here. So you can just copy this over, and then inside shared notes, I have this Google Sheet. If you want to just type in, like drop a note in there, and then the key that you use to do it, then we'll try decrypt the message. Let me know if there's I think there's like kind of a thing with Google Sheets that you have to actually paste it into the editor here, or else it'll like populate a few different fields. Cool. Yeah. You can use anything like. So I'll just take this one over here, and like we spend like maybe a couple of minutes to just play around with this. So to decrypt this message, what I'm going to do is just copy it. I'll go over here, and then in symmetric.asc, I'll just paste it down into there. So now I can type in the same commands to decrypt earlier, GPG-D symmetric.asc. It's going to ask me for the passphrase. This is a secret. Awesome. So you can just kind of play around with that if you want. Just a minute, and like I'll let everyone try to catch up for the next couple minutes. If anyone has any problems so far with doing a symmetric encryption or decrypting it, yeah, post a note in the chat. I do this one. I'll just paste this. Another poll. Is it working for you so far? Try this one. Secret. Secret places. One word. Secret message. Okay. Yeah, cool. Awesome. Secret places. Cool. All right. I guess yeah. So this is symmetric encryption. As we kind of talked about earlier, like the one of the big drawbacks of it is how would you sending like this passphrase, or having to send it along with the message. And of course, anybody with the passphrase is able to decrypt the message. So that goes on to kind of what are the advantages or great things about PGP is this implementation of asymmetric encryption. Asymmetric is the public key encryption that I talked about. Yeah, the video is being recorded. I just saw that message about, and yeah, symmetric encryption. Kind of where was yeah, asymmetric encryption is kind of great for not being able. You don't have to have all of the kind of this overhead of having a passphrase to send it with them. So in order to do this asymmetric encryption, you'll need to generate a public key pair. And you can do that using PGP to make a key pair for yourself. So for now, I will be showing to do the asymmetric encryption. Let's make the key pair, and we can generate a key pair with GPG dash dash gen dash key. The GPG dash dash gen dash key. So it's going to ask you for your name. A name here. For I guess for the purposes of REPL, this isn't like really going to be REPL. It like destroys the virtual machine after the session. So this isn't actually going to be any like permanent thing. So I'm making a temporary email for now, or test email, and I kind of recommend you do that for this workshop. Is just like mark@email.com or your name at email.com, because you do want to have like an individual or a unique email, because if we all have like test at email, there will be some collisions later. So just put an email here, type OK, and then it's going to ask you to type a passphrase to save your key phrase. I type in this, make a password. Oh, I put my email next to my name in the Google Sheet. Yeah, so actually, so for the purposes of this workshop, email in your Google Sheet, that's gonna be the email that you're using for the workshop. So that because you can use your real email or you can use yeah. So the one that you made with your key. Cool. So it'll create a thing, and if you have some problems before, like you might have to kind of have like kind of at least a 5-letter password, and maybe a number or something. If it keeps asking you to put in the password, there is some password restrictions. Cool. When you generate a new key, let me know. I'm going to do another poll here and just see were you able to successfully generate a key. And then you'll know that if you can see down here, it will have this kind of success message. If you make a message that is readable by multiple keys, I I don't know about this. I haven't used PGP in that way. But it's kind of be readable for multiple keys. Anyone knows about group chat? I think for now, you can make it. I know when you are encrypting it for a person, you have to put one recipient to encrypt it to. But that's not necessarily. You can try that. So I'm seeing that we have like 6 people who are able to get this far to make their key. Is there anyone who is having trouble or is in error? Sometimes REPL also like will crash, so you might have to rerun the program by pressing run at the top as well. Cool. What did they? Turns out you can. Awesome. We'll see that. So now, like, okay, I'm seeing that we have some more responses. I think we can move out on a little bit. So here, I want to like take a look at the key that we generated. We mentioned earlier that there is a public key and a private key or secret key. Let's take a look at GPG export secret key, and then the name that you emailed. Probably wouldn't really want to do this like in real life too much. So you have to --armor because if you don't do armor, it'll kind of show you binary or like a binary version. So here's my secret key that you can see here, PGP private key block. And this is the thing that I mentioned that you don't want to share. So like you probably wouldn't want to, in practice, you definitely wouldn't want to be doing this in person. But this is your private key, and if you ever need to, if you ever need to like use a different computer, and you want to retain your public key, then you can export this private key and then just bring it to import it to your new machine. Cool. Next, let's go actually export your public key that you made. GPG export armor. I think output, and then I'll make it my name key or public key .asc, and then my email. Okay. So if you do that, then you can export the public key for the email that you made earlier. So I made it with mark@email.com. It'll generate. So this is the step through it is export the key in ASCII. Then I'm outputting it in a file called public key.asc. And this is the public key that I'm exporting. It's mark@email.com. So then when I ran that, it'll generate this public key that you're able to freely distribute. And then you'll see why it's safe in a little bit to have it public. So what I'm going to do is copy my public key, and feel free to do as well. And then on the Google Sheet, there's an asymmetric tab. Here, and I'm going to replace this earlier. I had that earlier. Let me delete these for now. So I'm just pasting my PGP block or my PGP public key in here. And then my email is going to be, or actually, that's just smart. You don't need to put your email in there. I'll show you why. So, cool. So yeah, if you can do that, I'll show this again, this command again. GPG export. And in README, it has like all of the steps if you get kind of lost. Here. This is the command. We're here right now. Let me restart this polling, and once we get like quorum of people uploading their public key in saving it into here, and we'll move on. And I saw earlier that there was a no. So if you have a question, or if you're stuck with generating the key, just let me know in the chat what if there's like an error message or something that you saw, or something, or how I can help with that. The private key is export secret key -- armor. You could pipe that into the name used for the keygen. Export secret key -- armor. Mark. And the name I use is this. I'm going to ask for your password. So this would be it. your private key. And again, like you wouldn't really want to, well, unless you were like changing machines, then what you would do, I guess, is pipe this into secret mark secret key. And then that would have created mark secret key. It would have created this private key that you would have been able to export. I guess don't really, for this purposes, you wouldn't really need to show the public private key too much. Seeing 5 people have it in. Wanna like hopefully I can get some more people on board. Let me know if there was any problems. Hopefully I can get like, see how many, 31, like maybe be cool to get 10 people to send, to be able to follow along. Just in case that, just again, in case there is trouble following along with my steps, I have in README, there's all the tutorial steps that we are. So here, so the gem key is here. To make it to generate the key. Cool. Well, I'll just, since we're just running a little short on time, so let me kind of move on, and feel free to keep adding your keys as we go. Add the keys that you generate as we go, and let me know if there's problems. So here I'm going to show how to import a key. Like now, now that let's say you share your you share your key to somebody, you can send it through email, or you can send it to if you put your key on a website, then someone can take that key, and they can have to upload that key to their PGP program. So how that would work is you're going to take this public key here and just copy it in. There's going to be a folder, a file I made called public key.asc, or import public key. It'll be an empty file. You can type paste that import key, and then just paste the public key, someone's public key in there. And to import it, you want to do GPG -- import, and the name of the file, import public key. Or if you made a new file, then just the name of the file that you pasted it into. Cool. Then it should give you a message. So this is basically making the address book of this is making the address book for your GPG. So I'm gonna keep going down, and just feel free to import everyone's message keys. Shoot this down. Keep shrinking these down so you can see them a little bit better. So I'm going to keep uploading these, importing these in, just using the same file. So just pasting that, keep replacing them, and just running the same command. Is there another one down here? Cool. Cool. So now I'm now to see like a list of all the keys that you like. To look at your address book, you type GPG -- this keys. This will send. This will be the list of the keys that you have in your GPG key ring. Cool. So now you can encrypt a message for any of the people that you have on your list, so that only they can decrypt it. So let's go to let's go to the secret. Let's go to secret.txt here, and then I'll type a message over here. So what you would want to do now, you type in the message, and then you say you want to send encrypt this message so that only David, or you can use B, or only David or someone can decrypt it. So the command for this is GPG --encrypt --armor -r, and then you would paste, copy their name in, or their email, or you can use their name as well. So GPG encrypt armor to make it ASCII, recipient, and their name or email, and then the file that you want to encrypt, secret.txt. Then I'll just overwrite this file. So then they created a file, secret.txt.asc, and only only David would be able to decrypt this message. So I would take this file message. I'm going to take it and copy it over into here. And that would be paste it into a message for him. Then you can, if you try to. Oh, okay. Yeah. So that's definitely a problem with the REPL. Yeah. So if it crashes, and yeah, then you wouldn't be able to do that. Use it. But I'll just decrypt a new message for yeah. So that's why it's important to decrypt one. So if it didn't crash for anyone, I'll say hi Freddy, and then just to kind of show this audio GPG --encrypt armor Freddy -r Freddy secret.txt. And then I say yes, and then take this over here, and then I'll paste it in Freddy. And then I'll make one and then if anyone tried to decrypt it, then you would find that you're unable to decrypt it. Only Freddy can. So if you want to like send a message to anybody, or try sending one to me, yeah, just feel free to just paste this and drop it in this So I'll send one to this. So GPG dash dash zip. R. Any questions so far? So how you would decrypt the messages basically would be the same way. There was a message here. You would just copy it in. Say I copy this into the symmetric message.asc, and then I try to decrypt it. Decrypt d-c asymmetric. So then that gives me an error because I wouldn't be able to have. I don't have this message. Awesome. So anybody have any questions so far about this? Asymmetric encryption or symmetric encryption? Let's do a poll. Just one poll. I'm definitely losing people on the poll as we go, but let me know if a question about do you have a problem that I might be able to debug with you, or yes, you're okay. If no, let me just say no, and then also let me know. Cool. No. See some no's, which is good in a way. So where is the problem? If you want, you can also use me. This is my public key. I don't think it has been, our REPL hasn't crashed yet, so you can definitely send me a hi mark. GPG encrypt dash armor dash r mark at email.com. There is a problem with it. But if you wanted to tell me in the chat what is where you're at. Well, there is like a couple more things I wanted to show as well. So I like wanted to show like one other feature that PGP does is digital signatures. So which is a little bit different than encryption. Like signatures are a way to verify. So encryption is like scrambling the message. But as when we talked about the letter analogy or before, like one thing is that someone might change the contents of your message. So in like encryption or in PGP terms, there's a way to fix this by using digital signatures, which is a way to sign your document and then it gives evidence that there has been no changes to your document. So let's kind of show it over here. Like if you want to open up a signature.txt in the Explorer, and just type a message here. What you can do is do this. There is this GPG, and this digital signing that you can do, GPG dash clear dash sign signature.txt ASC, and then it's going to ask you for your secret key earlier. So this is kind of, it's signing the document with your private key. So that way nobody would be able to alter it alter the message and without and for it to be verified. So when I ran this message clear sign signature.txt, it created this new file called same signature txt.asc. So now this is in clear text, the message with the signature attached. So this is kind of common on like internet forums or like where you don't want to necessarily have like the encrypted message, but you still want to retain the verification that signature or PGP has. So that outputted this file here. So then if I type in GPG dash dash verify signature.txt.asc, if I verify this file, it will say good signature here. So that means that there has been no changes to the document. If I were to change anything about the file, so now I changed the file, see this document was changed. If I verify it, it's going to tell me that it's bad. So that means that there has been a change from in the file. And there's like a couple ways to do the signatures. Clear sign is a way that it creates a document like this, or like a new document with the signed message as well as the signature. This so other ways you could do it is GPG dash sign slash dash detach signature.txt. So that would have created, instead of creating a file with the message, it just creates a new binary of a detached signature. So then this would be something that you would send along with the document. So it doesn't like make a new document per se, but it's just something that you can now use to send along for other people to verify signature for the message. Cool. I think we're closing on the last like 15 minutes of the workshop, or like a little bit. That was like mostly of the content that I wanted to share. And I still see that there's like, I think there might be some problems with some of the earlier steps. So I want to use the time to like debug anything or try other things. And also, I kind of only scratched the surface on like PGP. There's a lot of things that I didn't quite cover in the workshop. If you want to learn more about it, I would definitely take a look at more about like key servers, which is another way to PGP key servers is where you can publish your public keys and not necessarily have to send them to each individual person. I would look at like key management, like how do you like keep these how do you keep track of these keys that you're having. And then there's like also more like other ways to do PGP. So you don't have to use it in the terminal like the way I'm showing now. PGP does have a GUI interface. I think if you use some email clients coming off from the top of my head, I'm thinking of like Thunderzilla, Thunderbird, which has like PGP client that helps you manage all of this. And if not, you can also like think about using Proton Mail, which is an end-to-end encrypted email. I mentioned that does use PGP in the backend, but this is just gives you a kind of an idea of the things what's happening behind the scenes of it. But I guess, yeah, please let me know in the chat how I can if there's any steps that we want to talk about or anything that I would like to, any questions that you have about anything. So actually there's the part 2 is actually going to be just a repeat of tonight. When I signed up, they kind of asked if they would have I didn't realize that they would break it, have a repeat. So it will be definitely covering the same materials. So you're more than welcome to join again if you want some more practice with this. Cool. Yeah, I think it's totally happy to have anyone come in and if you want to review these topics. I think I can definitely, if there's more like questions or like something that you want to go further into, I can let me know, then I can like kind of prepare some additional things for Saturday. So I guess here is I'm not familiar with Tuda and Nada. So I don't really have an opinion on it, but I'll definitely look into that. I guess. So I guess I know we looked at. I want to also say that we looked at PGP today, but I think the more hopeful that we got out of this workshop was a little bit learning more about what exactly is encryption, or what is asymmetric encryption. So I guess why it's also like kind of applicable is the way that like different encrypted messaging apps, like if you use Telegram or Signal, they'll use asymmetric encryption to run that. So kind of in the same way that we're using Google Sheet in order to be sharing these public keys, like Signal will have their own servers in order to manage all of their the key pairs, which is kind of just is the kind of the basis of how these apps kind of work, which is kind of neat to know. So I guess, and if you think about it, kind of how this works. Yeah, and if you think about how this works, like when you realizing that encryption happens more or less locally on your machine, then you don't have to be too worried about like your messages. If they're encrypted, you don't really have to worry about them being stored on, let's say, Gmail or on Signal's servers, because then you'll know that even if the encrypted messages are stored on them, then they can only be decrypted with your private key, which would be locally stored on your machine. And I see that there's a good skill. Yeah, there's a similar process of verifying ISOs. That is process called hashing, or like a checksum, or you perform like a SHA checksum, which is pretty similar to like the signature kind of thing. So what that does, it takes like the ISO information, and then it kind of runs through a hashing algorithm, and it generates basically a signature that you can check. You run a checksum on, and then if it doesn't match, then you'll know that there has been a change to that document or a program that you've downloaded. Cool. Oh, awesome. So I guess there's 5 minutes left. Thanks everyone for joining. I'll stay on till 8:30. But if you have any questions, please feel free to drop me an email. My email is markofthelamb.com. So if you want to email me there, my website is markofthelamb.com as well. And I'll be here on Saturday going over running another session of this workshop. And if you have questions or want to do more any other thorough things, or if you want any additional materials to be covered, just drop me a note and I'll try to add things in there. And I'll upload this on the recording on somewhere and make it available for you. So I'm going to stop the recording now. Thanks for coming.